I am Professor Antonio S. Marahas, and this is Digital Technique Fundamental. Okay, so let's have another example, but this time with a decimal point. Okay, so let's say 312.75 of base 10. We want this converted into letter A, base 2 again, which is our reference number system. Letter B, base 8. And letter C, base 16. Okay? So take note of this. We have a decimal point present in our given number. Okay? So, solution for letter A. So you have 312.75 of base 10 to base 2. So again, you make a series of 1. 1, 1, 1, 1, 1, 1. Base 2. Okay? So this is, again, 1, 2, 4, 8, 16, 32. We add, because this is 312. 64, 128, 256. Okay? Because the next number is 512, and which is greater than 312. So this will be disregarded. And then again, you find a number. Once you added, you find a number here. Once you added, equivalent to 312. So 256 is less than 312, so we will make this 1. So you have already 256. If you will add 128 to 256, that is more than 312, so you make this 0. 128 will not be added. So if you will add 64, we will try 64. So you have 10, carry 1, 11, 12. Then carry 1, 320, which is more than 312. So you will make this 0. So 64 will not be added into your number. Then we have 32. So you have 8, 8, 2. 288 less than 312. So you add 32. So 32 is 1. Then, if you will add 16, you will have 14, carry 1, 10, carry 1, 304, which is less than 312. So, you add 16. Okay? Then, what is lacking? If you will add 8, plus 4 is 312 na siya. So that means that this is 1. Okay? Then the rest is 0. So if you will add 8 again, that is 12. Okay? 312 already. How about 0.75? So from here, you add a binary point. If this is decimal point, this is binary point. Then you add another 1 here. So, isang 4-digit lang. And this one here, from left going to the right, if this is 1, this will have to be 0.5. Then, that is 1, diba? This is the binary number. So, that is 1 times 2 is 2, like that, diba? So, here, you have 1 divided by 2 is 0.5. 0.5 divided by 2 is 0.25. Then 0.25 divided by 2 is 0.125. Then 0.125 divided by 2 is 0.0625. So that will be our representation. So you place here a point, no? You bring down the point. Then you find a number which is equivalent to 0.75. And what is that number? 0.5 plus 0.25 is 0.75. Correct? So you make this 1 and this is also 1. Okay? So the rest is 0. Pwede niyo butangan yung 2 ka 0 or nothing. So let's just say we will put 2 zeros here for the sake of our discussion, no? So this is your base 2. So again, how did we arrive with 0.11? So we add, since the given number is 0.75, so we add 0.5 plus 0.25 is 0.75. Okay? That is why we make this 1, 1, and the rest is 0. Okay? So how did we arrive with 0.5 and 0.25? You have 1 divided by 2 is 0.5. 0.5 divided by 2 is 0.25. 0.25 divided by 2 is 0.125. 0.125 divided by 2 is 0.0625. So this is now your binary equivalent of the number 312.75 of base 10 is equal to this binary number. Okay? So you have now a binary number. It will now be very easy for us to convert that into base 8 or base 16. So how do we do that? For letter B, 312.75 of base 10, we want it converted to base 8. Now again, we have arrived, or we have already determined the value of that particular number, 312.75, into its binary form. So all we have to do again is to rewrite this number. So you have 1, 0, 0, 1, 1, 1, 0, 0, 0, 0.1100 of base 2. Okay? So again, base 2 to base 8, 8 digit. I mean 3 digit. Okay, so we count the number of digits after a binary point. 1, 2, 3. That is going to the left. No? 1, 2, 3. 1, 2, 3. So, square na siya. After a binary point, you count the number of digits going to the right. 1, 2, 3. Again, going to the right, ha? Delete from right to the left. This time it will be from left going to the right after a binary point. Now, since this is 0, pwede ka mag-add of 3 zeros, 2 zeros, I mean, para ma-square. But the answer is still 0, so you may remove that number. Except, of course, if it is 1. Kung 1 na siya, then you have to add 2 more zeros. Okay? Now, what is this? 1, 2, 4. The same gapon. Dili balihon ang counting, ha? Dili 1, 2, 4. That's still 1, 2, 4. The same. Then, 1, 2, 4. 1, 2, 4. 1, 2, 4. Then, you have 4 plus 2 is 6. Then, bring down the point. Then, you have 0. Then, you have 7. Then, you have 4. Okay? So, 312.75 of base 10 is therefore equal to 470.6 of base 8. Okay? Then, How about letter C, which is converting the given number into octal, or I mean hexadecimal number system. By the way, what do you call this one? It is called the octal point. This one here is decimal point, and this one here is called the binary point. Okay? So, let's convert 312.75 of base 10 to base 16. So, 312.75 of base 10 to base 16. Okay? So, again, we have already obtained the binary equivalent of 312.75 in binary form. So, we will just rewrite it. You have 1, 0, 0, 1, 1, 1, 0, 0, 0, point 1, 1, 0, 0 of base 2. To be converted to base 16, again, 4 digit. From right going to the left, that is after a binary point. So you have 1, 2, 3, 4, boundary. 1, 2, 3, 4, boundary. Okay? You can add here 1, 2, 3, 4 para ma-square ang imuhang number of digit per boundary. Then, from the binary point, you put the boundary, you count 1, 2, 3, 4 going to the right. Okay? So, since upat na ni siya daan, then square na siya daan. And in case nga kulang, then you have to add a 0 because adding or neglecting a 0 here, that means nga dili ma-square ang number of digit, will have an effect on your answer, your final answer. Okay, so this one here is 1, 2, 4, 8. 1, 2, 4, 8. The same ang counting. Okay? 1, 2, 4, 8. 1, 2, 4, 8. Then, you get the value. 8 plus 4 is 12. So, A is 10, B is 11, C is 12. So, this is C. Do not forget, there is no 12 in hexadecimal number. Then, you bring down the point. Then, 8. Okay? Then, 2 plus 1 is 3. Then, 1. So, in other words, 312.75 of base 10 is equivalent to 138 C of base 16. And this one here is what we call the hexadecimal point. Alright? So that is how to convert a number with a decimal point or a binary point or an octal point into another number system. Okay? So I hope that it is clear.